Hi, I will be doing a presentation about improving sustainability of water distribution systems through prediction of water main failure. And the presenter will be myself, Ahmed, and Abdel Hadi, and Hussein, and Atifa. Potable water is a critical infrastructure component to communities. In addition, municipalities are required to provide users with minimum expected level of service. Unfortunately, due to the burdened and complex nature of water distribution network, they have received the little attention of decision maker. However, thanks to digitalization, more data now can be collected and analyzed than ever. To develop a management plan to maintain such a water network to be more efficient, sustainable, and resilient. The problem is infrastructure is suffering from improper assist management practices and lack of proactive intervention, which in turn increase the probability of failure of water main. Such a failure has been causing several consequences such as increase of cost of maintenance, disruption of traffic, and others.
So, the main goal of this study is to promote the proactive interventions to prevent those consequences and hence improve the whole water distribution system in the city of Montreal. First, we will calculate the breakage rate of water mains, then investigate the most critical attributes which contribute to water main failure, and finally predict the failure chance of water mains. And here in the methods, tools, and techniques of each objective. For objective 1, we will calculate the number of breaks per kilometer per year for each pipe and then aggregate and visualize this for each material type to discover which materials are most prone to failure, and only those will be considered for further analysis. However, the breakage rate is more meaningful than the pure number of breaks, and the output of this stage is a descriptive chart. For the second objective, decision tree along with information gain feature selection advantage will be used to investigate how much each attribute contributes to the prediction problem. Also, a correlation analysis will be conducted to investigate if some attributes need to be excluded in some algorithms such as naive Bayes, and also to support the importance of attributes. The output of this stage will be the importance score of each attribute and if it's worth considering or not. For the final objective and for the sake of a final robust model, two approaches will be considered. The first is binary classification to predict if the pipe will fail or not, and the second is multi-class classification to predict if the risk to fail is low, medium, or high. In this regard, the 5 classification techniques will be used, namely decision tree, k-nearest neighbors, and naive Bayes, in addition to trying logistic regression and support vector machines. Finally, all the models will be compared based on different goodness measures, and the best one will be selected. RapidMiner, Python, and spreadsheets will be used as tools.
For this project, we have two datasets: the water mains dataset, which includes the age, diameter, material, length, etc. The other breaks dataset includes the water main IDs and the breaks that they have suffered in the past. Right now, we have taken the main attributes to be the age, diameter, material, length, and breaks. As we can see from the chart, most of the water mains are made out of either PVC, ductile iron, and cast iron. So these are the ones we will focus on. The most common diameter sizes are 150 mm, 200 mm, and 300 mm, and consequently, these are the ones which have suffered the most amount of breaks in our dataset. The number of breaks per kilometer is also the highest for cast iron and is very low for ductile iron and PVC. This can be attributed to the fact that the cast iron pipes are older than the ductile iron and PVC pipes.
Using decision tree, we could determine the level of importance of these four attributes we considered, and our objective at this point is whether the pipe has breaks or not, so it's a Boolean. This curve shows the ROC comparison between the three models we used so far: decision tree, nearest neighbor, and naive Bayesian. Here are the results and confusion matrices for the three models. Because our dataset is imbalanced, we should consider recall instead of accuracy. And as you can see, despite of high accuracy, recall percentages for true yeses are not so high. So we tried another naive Bayesian model considering pressure zone and road segment, which we already have in our dataset. And as you can see, the results was improved significantly. The remaining steps are include dealing with imbalanced dataset, and we might try support vector machine and logistic regression as they are very robust methods in case of imbalanced dataset. Another step is test the effect of homogeneity on the goodness of the model. And we would like to consider the other factors that could affect the chance of failure, like weather condition and criticality. Thank you.